So now in Chapter 3, well, starting in Section 3.1, we'll talk about congruent triangles. Now, congruent, which has this symbol, means the same shape and the same size. Congruent means same shape and same size. So triangles are congruent. If you were to fit one right on top of the other, they would match perfectly. And so here's our notation for triangle ABC is congruent with triangle DEF. And so the order that the triangles named in the congruent statement is very important. This means vertex A corresponds to vertex D. The second vertex listed, that would mean vertex B corresponds to vertex E. And the third vertex, vertex C, corresponds to vertex F. So the order is very important in the naming convention. We want to know which angles are congruent with each other and which sides are congruent to each other. So here we have two triangles, and we're told that triangle ABC is congruent with triangle DEF. ABC is congruent with DEF. That means all three angles are congruent and all three sides are congruent. So that means angle A and angle D are congruent. See the single ticks? That means angle B and angle E are congruent. See, they both have 3 ticks. And that means angle C and angle F are congruent. See, they both have 2 ticks. And now as far as the side lengths, they are also equal in measure. So side AB is congruent with side DE, single tick. Side AC, that one has 3 ticks, congruent with side DF. And then here, CB congruent with FE. So there are 6 really congruent relationships, 3 sides and 3 angles. So if we have triangle ABC is congruent with triangle DEF, we know which angles are corresponding to each other, and we also know which sides correspond to each other. So here we know that AB, segment AB, is congruent with segment DE. Or we would say the length of AB equals the length of DE. Hopefully you remember the difference. Segments are congruent, measures are equal. So corresponding parts are equal. So in the correspondence, the sides are indicated by little ticks or black marks. The congruence, it might be a single tick, 2 ticks, 3 ticks. And the congruence may be stated with their vertices in different order, but the angles still have to be corresponding. So if I say triangle BAC, that's fine as long as this is EDF. Vertex B still has to correspond with vertex E. So the naming of a triangle in their correspondence is very important. All right, so let's go ahead and try this example here. Here we're told that triangle RST is congruent with triangle XYZ. So without drawing a diagram, let's see if we can answer these questions. Name the vertex of this second triangle that corresponds with T. 1, 2, 3. T is the third vertex mentioned. So the third vertex in this triangle would be vertex Z. We would say vertex Z, and that's also angle Z. T is the last mentioned, so Z is the last mentioned. T and Z correspond to each other. Let's look at B. Name the angle in triangle RST that corresponds to, or is it congruent to, angle X. Well, vertex X is the first one mentioned, which means angle X is the corresponding angle. So the first angle mentioned in triangle RST would be angle R. Angle R corresponds to angle X. And we're just getting this, so we're practicing the naming conventions. So name the side of RST that corresponds to XZ. All right, X is the first vertex and Z is the second vertex. So if I go to this triangle, I want the first vertex and the last vertex. Side RT would be congruent with side XZ. And considering the ordering of the vertices, name the triangle that corresponds to YZX. Y corresponds to S, Z corresponds to T, and X corresponds to R. So we would say triangle YZX is congruent. The corresponding vertices have to be listed in the correct order. So two triangles are congruent if all 6 parts of the first triangle, 3 angles and 3 sides, are congruent with all 6 parts of the second triangle. However, the nice thing is that in order to prove that triangles are congruent, you don't really have to find all 6 parts. You can find a fewer number, and we're going to cover that in this section. So, as in other definitions, this is also reversible. So if all 6 parts are congruent, then the triangles are congruent. So here, if we were to look at these triangles here, we would say, so here we have triangle MNO and triangle RST. These actually look like they are the reflections of each other across a vertical angle. Across a vertical line. Because angle M is congruent with angle R. Angle N is congruent with angle S. So all 6 parts of both triangles are going to be congruent, but we will only have to establish a smaller number, a fewer than all 6 parts, to prove that they're congruent. Okay, so a triangle is always congruent with itself. If a triangle is congruent with one triangle and that second one is congruent with, you can change the order of how the triangles are listed in the congruence statement. That's the symmetric property. And if ABC is congruent with DEF and DEF is congruent with GHI, we could say the first is congruent with the third. So how can we prove that two triangles are congruent without proving all 6 parts? Well, the first is called side, 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 and we're going to call that SSS. But we don't say SSS, we say side, side, side. If the 3 sides of one triangle are congruent with 3 sides of the other triangle, then the triangles must be congruent. If all 3 sides are the same length, then the triangles must be congruent. So here we have an example here. Let's see. Here we're given that segment AB and segment CD bisect each other. So AB is bisected, which means that segment and that segment are equal. That's what a bisector does. It cuts into two equal lengths. And CD is also bisected, so these two segments are now equal in length. And we were also told that AC is congruent with BD. All right, so what do we have? We have AC is congruent with DB. That was given. We have AM is congruent with MB. That's because of the bisector. And we have CM is congruent with MD. This is a side, this is a side, this is a side. All three sides are congruent with each other. So these two triangles are congruent, and the reason we can say they're congruent is called side, side, side. Now, once again, order is very important. So, as I go around this triangle, this is triangle TUV, I would say that angle U is included as I go from TU to UV. Side, included angle, side. Okay, so as we go around the triangle, the included angle lies between those two sides. The included angle lies between the two segments. Also, if I were to have a triangle, and let's call this TUV, if I have this angle V and this angle U, I would say the side UV is included between UV, angle V, and angle U, because we would do angle, then a side, then an angle. So following the triangle around in order, an angle, the included side, and the next angle, you want to just make sure that everything is named properly. Because there is a second reason for showing that triangles are congruent, and that's called side, angle, side. A side, its included angle, and then the next side.